Hello all, welcome to i-tutor Academy. In today's session, we will start with the subsection 5 of Unit 1, Mmpc 009. So in last video, we started Unit 1, so the subject Mmpc 009. So please refer. And today's topic start with the types of production system. So, looking from a different point of view, the entire problem of the production or operation management can be visualized as that of managing the material flow into, through, and out of the production system. If we try to detail out the flow characteristics inside the conversion system, we shall find that some systems have very smooth and streamlined flow. Some others may have more complex flow characteristics. In general, the more complex the flow characteristics inside the system, the more difficult it becomes to manage the system. On the basis of material flow characteristics, the production system can be grouped into the following four categories. That is mass production or flow line production system, batch production system, and job shop production, unit manufacturing or projects. The main focus of production management problem will therefore depend upon the type of the system. Problems which are very crucial for mass production may not be relevant for batch production and vice versa. It is therefore very important to identify the type of system we are managing and then focus on main problems of planning and control relevant to that system. A brief description of these problems are given in the following subsections. So here is one figure, material flow characteristics of a typical production process. Okay, so please refer this. Input is there, output is there, in between there is information about raw material, then it go to work in progress, then finished goods is there. Okay, so mass production or flow line production system, it's a continuous flow production or mass production situation are those where the facilities are standardized as to routing and flow, since inputs are standardized and therefore a standard set of process and sequences of process can be adopted. These systems have simplest flow characteristics constituting straight line flow, and facilities are arranged according to sequence of operation where the output of one stage become input to the next stage. The whole system is cascaded. The major production management problem in mass production systems are balancing of production or assembly lines, machine maintenance, and raw material supply. In a production line consists of the series of production centers. If workload is unbalanced, then the most bottleneck production stage will govern the whole output rate. This will result in increased throughput time and poor capacity utilization, thus contributing to low productivity. Hence, a productions or assembly line should be designed such that its workload is as evenly balanced as possible. Maintenance becomes important because if any production stage is under breakdown, it will block the whole line unless quickly restored back into operation effectiveness. So the raw material to first stage is important to avoid shortage and subsequent starvation of the whole line. There are methods and techniques available to attend the above mentioned problem areas. Some of these will be discussed in a later unit on operations planning and control aspect of mass production system. Characteristics. The main features of continuous production system are as follows. The volume of output is generally large and goods are produced in anticipation of demand. The product design, the conversion process, and the operation sequences are standardized. Identical products are produced. Machines and equipment are arranged according to product layout pattern. And special purpose automatic machines are used to perform standardized operations. Machine capacities are balanced so that material are fed at one end of the process and finished product is received at the other end. Fixed path material handling equipment is used due to the predetermined sequence of operations. Merits and limitations. Continuous production offers the following advantages. The quality of output is kept uniform because each stage develops skill through repetition of work. Any delay at any stage is automatically detected. As a result, there is automatic control of time and the direct labor contact is reduced. Work in progress is minimum on account of sequence balancing. Handling of material is reduced due to the set pattern of production line. Control over materials, cost, and output is simplified. The repetitive nature of process make production control easier. Overhead cost per unit is reduced due to spreading of large fixed cost of specialized equipments over a large volume of output, and there is quick return on capital employed. And continuous system, however, is very rigid, and if there is fault in one operation, the entire process is disturbed. Due to continuous flow, it becomes necessary to avoid piling up work or any blockage in on the line. Unless the fault is cleared immediately, it will force the proceeding as well as the subsequent stages to be stopped. Suitability, the continuous system is best suited to organization which intended to produce a limited variety of products on a large scale. The heavy fixed cost of specialized equipment that are utilized for operating at low cost per unit can be distributed over a high volume of output. Electronics, electricals, pins, clips, buttons, automobiles, bicycles, and container industries are some of the example of mass production. And next one is batch production system. Batch production has been defined as the manufactures of a product in small or large batches or lots at intervals by a series of operations, each operation being carried out on the whole batch before any subsequent operation is performed. Characteristics, the essential features of batch production are given below. A large variety of product is manufactured in lots or batches. Both general purpose machines and special purpose machines are used, and variable path material handling equipment is used. Machines and equipments are arranged according to the sequences of operation. Process layout is followed. Merit and limitations. Batch production combines the features of both the flow production and the job production types. Some degree of specialization is possible and capital investment is comparatively low. But work in progress inventory is high and large storage space is required. Due to frequent changes in product design, no standard sequences of operation can be used. Machines setup and tooling arrangements have to be changed frequently. And the main problem in batch production is the ideal time between one operation and the other. The worker has to wait until a particular operation is carried out on the whole batch. Suitability, batch production is applied when either the volume of output increases, resulting in some repetitiveness, or the market demand is not uniform throughout the year. In the latter case, occasional discontinuity in production occurs as switching to other product becomes necessary. And industrial blowers, motors, book printing, export production, drugs and machine tools, etc., are common example of batch production. And job shop production involves the manufacturing of a single complete unit with the use of a group of operators and process as per the customer's order. A uh, job shop does not have its own standard product and accept whatever customer orders come in. And characteristics is there. The product manufacturer is custom made or non standardized, and machines and equipments are arranged or assembled at one place. A wide range of general purpose machines like grinder, drill press, and shaper, etc., is used, and volume of output is generally small. Variable path materials handling equipments are used. Merit and limitations are here. A job production involves comparatively small investment in machinery and equipment, and it is flexible and can be adapted easily to change in product design. A fault in one operation does not result into complete stoppage of the entire process. And suitability, job shop production is applicable where custom made products are to be produced on a small scale, or typical example of job production are special projects, models, prototypes, custom clothing, jigs and fixtures, repair in existing machinery, repair and overhauling of automobile vehicles and construction equipments and sub assemblies, etc. And next is unit manufacturer or projects. Project is defined as an endeavor with a specific objective to the met within the prescribed time and cost limitations that has been assigned for execution. Characteristics are: project has a definite start and finish, it is executed in a time bound schedule, and it needs resources and skills of diversified nature, and it has a definite and definable goals or end result that can be defined in terms of cost schedule and performance equipments. Project passes through distinct activities which constitute project life cycle. Merit and limitations are there. Planning and scheduling of activities and procurement function are critical to the success of the project. Inventory is mainly concentrated in product itself, and material always flow in the same direction. And reducing inventory simply means shortening the delivery time and is equivalent of using equipment to the maximum of its capacity. And suitability: suitable for construction, erection work, and commissioning of plants. Management of materials in production system. So, material management is defined as the grouping of management functions supporting the complete cycle of material flow from the purchase and internal control of work in process to the warehousing, shipping, and distribution of finished products. Role of material management. Materials in India context constitute more than half the total cost of production in most industries and projects. In some industries, 60 to 70% total production cost is due to materials. This makes material management the biggest single area having tremendous potential for the cost reduction. A well coordinated materials management program may lead to 15 to 20% cost reduction. Objectives: the primary objective of a company is to reduce the costs that occur while buying, storing, handling, transporting, and packaging materials. In addition, material management has the following objectives: maintain steady flow of materials, ensuring that production does not get interrupted; adopt cost reduction techniques like MRP and value analysis to manage the total cost required for proper management of materials; provides right material in the right quality and right time to ensure the production of high quality product; implement scientific inventory control techniques to reduce investment; and maintain records of the store and purchase, etc. Preserves stocks so that any loss of material caused due to deterioration, pilferage, and obsolescence can be kept at the minimum. Improve producer customer relationship by producing high quality product, and minimize wastage of material and therefore reduce operating cost, and dispose surplus material, metal cutting, and chips to economies on cost. Need for integrated approach to materials management. To be most effective, our desire to maximize material productivity must aim at getting most out of every rupee invested in material. This calls for a well coordinated and integrated approach towards various problem area involving decision making with respect to material. Another important area to improve efficiency on material management front are value analysis, purchase price analysis, and materials handling, inventory control, store management, and waste management. An integrated approach to material management must look at all the above mentioned problem areas in a coordinated manner with a view to maximize material management effectiveness. Cost involved in material management. Managing material involves the following cost: that is capital cost of material procured, paid by the company to the supplier; government levies and taxes; ordering cost involving the cost of tendering, stationery, postage, inspection, bill payment, and delivery that incurred while purchasing material; Inventory carrying cost, that is holding cost, involving cost of storage, record keeping, wages to stores staff, and payment of insurance cover for maintaining inventory, and packaging cost, and material handling cost, and shipment cost. Okay, so this here is product life cycle. So here is time is there, volume is there, introduction growth stage is there, then again there is the decline. Okay, so this is product life cycle. And next is concept in system life cycle. The life cycle concept or warm to tom concept draws analogy from living organism, and it assumes that every system has a definite life cycle, and it passes through growth, maturity, saturation, and decline phases. And here is figure 5 shows a typical life cycle of a product. And here is life product life cycle. So there is an introduction, then growth is there, then maturity space of a product is there, then again it go to decline space. Okay, so that is and the stage in system life cycle. So stages in system life cycle we already discussed. There is an introduction stage, one product is always introducing, and then it grow, and then it one maturity space is there, maximum profit from that product, and then it decline again. So next is life cycle costing. A very important concept in costing has emerged in recent years, that of life cycle costing. It says that when we evaluate the cost implication of our decisions, we should not consider the short term cost alone, but the entire cost during the life cycle of the system and equipment. So, this long term cost repercussion must be examined rather than immediate short term cost alone. So here is the stages and key decisions. So there is a birth of the system, that is initial stage of a product, then identification of corporate goals, selection of the product is there. Second stage is production design and process selection is there, technical design of product, selection of manufacturing technology, sequence of manufacturing is there, key decision areas. Then third stage is design of the production system, facility location or layout, design of quality, demand or forecasting is there. Then manning the system, jobs structuring, allocation, assignment method, design, work measurement, payment system is there. Fifth is system startup, how to overcome initial problems, how to achieve full capacity. And next sixth stage is system in steady state, operational decision, cost reduction studies, improving system performance to look after day to day problems. Then revision of the system, updating various decision in the light of external changes, death of the system, how to phase out and salvage resources, sustain by starting new product, etc. Okay, so this while making important decision regarding design and planning aspect of production system. And we should consider life cycle cost. This could even be converted to present values by discounted cash flow techniques, accounting for the time value of money. So, next stage is role of scientific method in operation management. Method and techniques of scientific management have tremendous role to play in helping us to make rational and logical decision in the context of production and operations management. Through scientific method, tools and techniques of industrial engineering and operation research along with behavioral science, we can look at all phases of problems and evaluate the consequences of our action before arriving at a decision. The role of industrial engineering. Indian Institute of Industrial Engineering IIIE has adopted the following definition of industrial engineering. Industrial engineering is concerned with the design, improvement and installation of integrated system of men, material and equipment. It draws upon specialized knowledge and skills in mathematical, physical and social science together with the principles and methods of engineering, analysis and designed to specify, predict, and evaluate the result to be obtained from such system. It can therefore be seen that industrial engineers are designers of management system, and industrial engineering approach integrated various approach such as operation research, system analysis, behavioral science, etc. And the role of models, the models are representations of system with a view to explain certain aspect of system's behavior. Generally, mathematical model is preferred in decision making because it tries to explain systems objectives and functions in terms of decision variables subject to our control, as well as non-controllable parameters due to environment or resource constraints, etc. Thus a simplified form of a model. So, role of computers in a large sized problem, a computer become a very efficient tool in problem solving and evaluation of alternatives. The role of behavioral science, since people are integral part of our production system, so understanding of human behavior is very important so that managers can evaluate the consequences of their actions on human relation and moral motivations and productivity, and supervises relationship with his subordinates, organization structure, individual and group behavior, work habits and attitude, incentives, participation in decision making, and performance appraisal system have impact on worker morale and motivations. Next is historical development of operational operations management. Historically speaking, the field of operation management has evolved in very short span of time. So its roots, however, go back the concept of division of labor advocated by Adam Smith in his book The Wealth Nation in 1776. In 1832, Babbage, a mathematician, extended Smith's work by recommending the use of scientific method for analyzing factory problems. Okay. However, the era of scientific management, as it is now known, started with the work of F.W. Taylor in 1878, who subsequently came to reorganized as the father of scientific management. Taylor is credited with the reorganizing the potential improvement to be gained from analyzing the work content of a job and designing the job for maximum efficiency conducted on the shop floor, and it brought about significant and rapid increase in productivity. And Taylor described his management philosophy in a book, The Principle of Scientific Management, published in 1911. And this, even more than any other, can be considered as the beginning of the field of operations management. In 1930, again, the Harrington Embers applied Taylor's idea to develop organization structure and suggested the use of expert in organization to improve the efficiency. Okay, so like that, this is a history. In 1933, there is Elton Mayo conducted his famous experiment at Western Electric's Hawthorne plant looking into human and social aspect of work. In 1937, there is LHC Tippett developed the concept of work sampling to gauge the level of machine and manpower utilization and for setting work standard. So please just read this history of this, from Unit 1, and this is subsection 9 of MMBZ 009. This is all about the history of operation management, so you just read this. Okay, so you will get an idea. Till there is 2000, the recent quick adoption in internet and world wide web during the late 1990s and early 2000 has revolutionized our thinking, in which we collect information, do shopping, and communicate with the rest of the world. Okay. So, summary of this unit is here. So, this unit has attempted to give a general overview of operations management, a system approach treating each operation as a value addition process has been described, and the concept of operation management include both the production of goods as well as the services. We already discussed all these things, and in brief historical profile of the subject also we now discussed. Okay, so that's the summary, and keyword section is here. If you feel any words are difficult, you just refer these sections and you will get the explanation of each word. Okay, and the self assessment exercise also here. Okay, around 11 questions are here. You try to do it from this, and all questions are direct and we already discussed. In between any doubts, you can contact us anytime. For more MBA videos, you just do like, share and subscribe our channel. Thank you so much.
i-tutor Academy presents Ignou Mba complete syllabus coverage classes for individual students, semester-wise subject with online and flexible timing. For more details, contact on +916 238 217 885.